picking up good vibrations.
In this short video, we will talk about the frequency interpretation of the Fourier series and we'll outline what will follow. Now, the Fourier series can be seen as a transformation between a very broad class of periodic signals and an infinite set of coefficients, A0, BKs, and CKs. Now, each of these BKs and CKs is associated with a cosine or sine that has frequency 2 pi over capital T k. So as k increases, these frequencies will be higher and higher. Now, if the signal varies smoothly and in a slow manner, we can represent such a signal with a few of these Fourier series coefficients. Take, for instance, the periodic replication of the Mexican hat, and we have seen that with only 3 or 4 of these coefficients, we can get a very accurate approximation. In turn, if the signal changes abruptly, in the limit it can even be discontinuous, like the rectangular wave, we need many of these coefficients to capture the details, the high frequency details in the signal. And we have seen that for a rectangular wave, we needed a lot of coefficients. Even 50 would not be enough to get a very accurate approximation. So, from the Fourier coefficients, you can have a very good notion of how the signal looks like, and you can see this as a decomposition of the signal in the frequency domain. This frequency is 2 pi over capital T times k. Now, the Fourier series is the first building block for what will follow. We will extend this notion of the Fourier series, which is a characterization of continuous time periodic signals, into the Fourier transform, which is a characterization of the continuous time aperiodic signals. Then we will translate these representations to discrete time. We'll have analogous results there. Discrete time Fourier series that represents discrete time periodic signals and the discrete time Fourier transform that characterizes discrete time aperiodic signals. And finally, we will talk about the DFT discrete Fourier transform, which is yet another transform that is intimately related with the discrete time Fourier series and the discrete time Fourier transform.